This little video is here to remind you some methodology for biodiversity census, so census. I'm sure most of you already did some of them, but let's remind us for ecologists for what we do biocensus. Obviously, for point zero, for example, you start a reserve, a marine park or something, and you need to know, or you plan to do something like that. You need a point zero. You need an overview of your area in a biological point of view. Also, for before and after control impact, for example, there is a dam or a deforestation or reintroduction project, something like that. You need to know what is the state of your community, of the biodiversity before and after the impact, and also just a monitoring to check the evolution with time. We have to do biodiversity census. For that, there is a few techniques. Let's have a look. There is many more, and many more will come probably, but let's have a look, and also I will show you some news with technology now. So you probably did some transect. You know, transect is good, for example, for mobile organisms. It can be underwater. For example, you follow a line, a straight line, and if it's for motionless organisms, for example corals, you will count all the colonies in contact with your line. Or can be for plants. I know you do animals, so I won't talk about plants. So corals, it's fine. Also, you can do that to have an overview of animals into a corridor. So either you follow the line and then you will record all the animals you can hear, you can spot, and then it's important to record the distance from your line. Okay, so either you have a line and you count species into a corridor or in contact with your line, or you will count species in a virtual corridor. It can be used also for fish if you are in underwater and you have a corridor and you have to count all the fish the species you will record in this corridor. But don't forget for the distance from the line, because after that you can do distance sampling. So distance sampling, it's something that can help you to estimate the density of your species. So if you record several species, you can do an estimation of the abundance for each species. Sometimes you will just record one species, so it's not a biodiversity census, you will just census one species, and then you want to know the density into this corridor. For that, you need to record the distance from you, and then there is a software, distancesampling.org. Have a look. Distance can be also on R, but for this one, let's have a look. It's quite convenient because it's button press, but you can do it in R also. Actually, I teach with R. And then what you will have, it's something like this. So imagine here, this is your survey area. I think it's a cool demonstration on the site. So it's almost an entire course for distance sampling. So have a look to here. You have many course training also here, but I just give you an introduction for you to know that exists. So imagine you have your survey area. Here it's only one species, okay, the blue dots, individuals. So when you go, you do your census, and then from 0 to 1 meters, etc., etc., you will record a maximum of the present individuals. But far away from you, you will have less chance, a lower probability to record them, okay, because you are less efficient, you cannot hear them efficiently, they hide better, or they will escape. So at the end you will have something like that, a probability, a frequency, and then a probability of sampling according to the distance. And then in this corridor you will have an estimation, quite accurate, of how many individuals you saw, and you can see in the entire. So after that you can extrapolate with this sense. You can extrapolate what is the density of individuals into your surveyed area. Okay, I hope I'm clear, but have a look to distance sampling. So when you do transect, if you also record the distance from you of your individuals recorded, you can also calculate an estimation of their density. Okay, let's return to Prezi. So it's quite convenient, but it's a big course also to play with distance sampling. But you have to remember that it exists, okay, for you. And then you can also provide, make some very nice map with density, you know, with gradients of color, etc. You have to keep in mind that now it's possible to do this kind of sampling with transect using drones. You have also now some planes. You have some plants flying, and then you have with laser they can map in 3D the shape of the trees, for example, and also with the infrared signature and the light signature they can determine the species they record. So they make a very nice transect, and below them they can record the species of trees in a forest according to the shape and also to the light signature. That's cool. Huh? You can do that with drones also. I put the drones here for transect, but they can be used also for big square or for entire area. We'll talk about drones also later. Okay, so keep in mind you have transect. When you have motionless organisms or insect arthropod who doesn't move a lot, you can use quadrats. Quadrats quite often it's for botanists, it's true. So for example here you do several quadrats every certain determined amount of distance, and then you can check the effect of the forest nearby or other factors. For invertebrate in tidal area, for example, you can check for invertebrate, etc., etc. You can use quadrants. After that, you have to think about randomization, etc., etc. But I won't talk about that here because you know how to do some good sampling protocol according to the factors you want to study. Okay, but just here I want to remind you the techniques for biological census. Also, you can use traps. So traps are fixed. Here you have the Malay traps. You can use also this kind of traps with light during the night, attracting a lot of insects during the night. You can use that, for example, collecting insects or things like that, falling from the ground. It can be also for pollens, seeds, etc. Here you have pitfall traps for insect reptiles. Me, for example, I use them a lot for snakes. It's very surprising, but snakes, they are curious and they come inside and they cannot escape anymore. So it can be quite useful to census amphibians, reptiles, arthropods. Sometimes you have to decide, depending on the species, if you bet them or not. If you put some bet that change the species you will target. Okay, so think about that. It's not the same if you bet. You put some bets inside. Here for insects, they use also something to to conserve them. So it's quite a destructive method. For me, I can give you a reference. I use something non-lethal, okay, for insects. So there is some risk. You will lose maybe some species that will escape, but depends. For me, it was a comparison of two ecosystems. It was okay, and we saw the differences. So you have to decide, but it can be destructive. Another indirect way for samplings, for example, there is a recent paper about sharks. You can, for example, check the record of catch for hunting or fishing. So it's quite depressive for biologists, but you will see a good view of your ecosystem and the species, not thanks to, but accordingly to what the exploiters do, and in your interested ecosystems. So for example, in the sea we use a lot of the fishing records to do some biodiversity census. Okay, so you have also indirect way to do some biological census. After that, you can also have fixed position. Into the sea, for example, you are underwater in a spot, same, you did some random positioning, okay, according of your question. You have to take care of that, obviously, but this is not the subject. So you have a fixed point, you are motionless in scuba diving, for example, and you have a column of water. You have to put some, and for example, poles or something to help you to figure out where is your column, virtual column, and you will count all the fishes that enter into or already present into this column. Okay, so for that you need the same observer, because it can change a lot from a diver to another diver. So for example, for me, when I did this kind of census in coral reef systems, so I was alone. Check also the depth, because if you check the fish in a depth of 5 meters and 20 meters, obviously it's not the same, and you have to record all the factors. If you have sand cover, coral reef cover, obviously the depth, etc., etc. So, but remember, you have fixed position and you record all the fish. For example, can be the same for birds. In many countries, for example, every year you have a specific day where biologists, ornithologists stop in a specific area, not recorded with a GPS, and they listen all the birds they can recognize, and they estimate the direction and also the distance, and then you can have a good view of the biodiversity, the ornithological biodiversity of your area. I left also in fixed position all the things. This is not biodiversity census, it's more counting for range species, but they can use it. For example, when you have a beach with several species, you can use drone, and here it can be specific fixed position. For example, you have a huge colony and you do sampling in fixed position. Why not? Honestly, I was not sure where to put this, because it can be at several places. It can be at quadrats, but most often it's exhaustive. When you have a drone, the drone takes pictures of everything and you will have something exhaustive. Let me talk about what Jason did. So I met Jason in Australia, very nice guy, and I was very astonished by what he discovered. He did his PhD about the use of drones to count big colonies, and he did a very cool experiment. Actually, he thought maybe he developed actually something for the drone to take pictures and then to count automatically with a EA, artificial intelligence, AE, sorry, how to count the birds. So you see, higher you are and more pixelized your birds will be. But even here, you can say, I got a bird. And then he said, wow, my drone is so cool, I'm sure it can be better than human. So, but how can we can we be sure? So he bought actually some artificial duck. He put it on a beach in Adelaide, and only him keep its secret number of birds, of ducks. So he installed them on the beach, and he asked some very experienced field ornithologists to count, as they usually do, like you, maybe you are, and they counted exhaustively the the artificial population. Okay. Then also he took pictures with a drone and asked some people to count 1, 2, 3, 4, 5, like you can do. And then also he asked his artificial intelligence to count. So guess what was the best? The drone with the AE. So it was from 50 to 96% more accurate than human, than even experienced field biologists. So very promising, because also depend of the species, it's less disturbing. You can count exhaustively and very precisely. If I remember well, have a look to his paper. If I remember well, he left like 646 ducks, and the drones count 650, and the human 620. So it was very nice, very interesting. So be aware about the technology, new technology, and their use for biology and biologists. As I told you, it's very good for you to have some little specialty. If you are good with drone, you really like to play with drone, this is something. This is a new domain for biologists, the use of drones for biology. Something very efficient to do biological census are bioacoustics with sound recorders. So you live, because you have an ecological acoustic environment around you. Maybe now you can hear some birds. So this is the same in a forest, same underwater, same in a little pond. I met a biologist. I was very surprised because forget about the silent world of the sea. It's full of noise, and many of the noise are obviously specific to a specific species. So he's making a big database of like a bibliothèque, like a big database of sound and for fish. And now the goal is to put a sound recorder, and then you can just analyze the sonogram, okay, the signature of the sound, to say, here, for example, I have a pufferfish. Here I have a humpback whale, which is actually true, humpback whale. So, because each species got a DNA signature, a vocalization, so a sound signature, bioacoustic signature, etc., and a obviously a image signature. So it's where we use camera traps. So together in 2 weeks, I will teach you just to practice how to use camera traps. So I left it here like in fixed position and not in traps, because it's non-lethal. So I prefer says it's fixed position inventory. It's quite nice. I have a lot of pictures. I use them in Congo, and you can inventory a lot of cool species. Let me show you a little video. Why not, just for you to know another. It's look like a camera traps, but it's actually a bioacoustic traps. Please come on. Same, just 1 minute to watch a video. It's always good. It was good and cool. So depend which groups you're targeting. Frogs, birds.
This
It can be
is
very
the Bar
useful.
LT by Frontier Labs in standard mode. It has two microphones, one facing at the bottom and one towards the left. And if we open it up, here we have space for 6 batteries. Here we only have 4, but each one provides up to 100 hours of recording time. And then we also have space for 4 SD card slots, but we only have 1 in at the moment. And then if you have a look on the screen, we can see our battery life. We can see confirmation that we do have GPS location here, that both microphones are working, and this is our SD card memory space. It also says we don't have any recordings set up at the moment, but it's very easy to set them up. So if we go into the menu, we've got recording schedule there. We can choose to make a new entry, and then we can choose when we want the recording to start. We have 3 options for this. We have clock-based, which is based on a clock time that you put in yourself. And we also have sunrise and sunset based, which goes off your GPS location and works out sunrise and sunset times based off of this. So if we go sunrise based, and then we can choose when against the sunrise we want it. So say if we want it 2 hours before the sunrise, we can start that tomorrow. And we want that to last for 4 hours. And then we can choose whether we want to repeat it, and in this case we won't. We can choose our sampling rate, how many microphone channels we use, and this is our file type. If we just click save, we then have our sunrise entry here. So if we go back, now says our next recording is due at that time on that date. And all we need to do is close it up and leave it for the sunrise.
Et voila. So, sounds cool, sounds easy, and what is important, that can replace an assistant from you. For you, for example, you have to do some census, at least you have something quite efficient, powerful, doesn't need to eat, is not afraid about rains, sun, etc. And it cannot miss individuals that sing or that will pass in front of the laser. Okay, so same for example with bioacoustic recorder, hydrophone, you know, you dive with it, or you put that on your boat, and then you will sample the acoustic environment and to check, for example, for fish, for whales, etc., etc. Voilà, you understood then the philosophy. What else? I want to show you the environmental DNA. So this is not the future, this is now. So very efficient, super powerful. So for example, you sample some drops of water, even drops of water, that can work. And then you extract the solid particles, but you can just drop it in a solution, then you will amplify your DNA with specific amorphs. Oh, I lost my word in English. With specific codes. Quite often they use something from the mitochondria. Okay, they're like COX. You maybe heard about the COX signature, which is a piece of it's a piece of mitochondria that DNA that we all have, we share, and then obviously we have specific signature if I'm a human, or from a dog, a fish, or even a gastropod. And then there is a big database now full of those signature, and from this DNA amplification you amplify the COX, for example, piece, and then you will see if there is change with AT or CG, things like that. So, and then with this DNA signature you can know which species was here, here, or here, because all the animals in the water, even into the air, or stepping on the snow, will leave piece of DNA. Now my room is full of particles, dust from my skin, can be mucus, can be sperm. I mean, not from me, but I mean, you see what I mean? In water, air, or snow, it's full of pieces of DNA from animals, organisms who was here. Can be the same with mushroom, into the hair, pollens, etc., etc., etc. Okay, so meta barcoding, you can have a lot of species recorded. You can even record the change in time because you have a slow degradation. You have a lot of publication about that. Have a look. You have a specific degradation of DNA, and then with time, if you fish path yesterday, you will still have DNA. 1 month, you will have few DNA, but still recordable. And from a year, maybe not. Okay, even to do some they do sampling from sediments from the past, from ice, mixed with soil, and you can do some very cool biodiversity census even from the past with that. Just an example, for example, just you have a tracks that you cannot recognize. Biologists, you just check strange tracks. You take some samples of snow, and you can recognize that here it was a lynx. That's what they did, for example, here in Canada, or to record some very elusive species, very hard to record. So you see, there is a lot of techniques. Most of us, we know the technique involving a human, but it's sad, but very efficiently are the automatic techniques like the bioacoustic recorders. Oh, I forgot to talk about fixed position. You can be in a fixed position and you have a bat recorder, okay? And during 1 hour you listen for the bats, and obviously you can do it also automatically. You have this kind of bioacoustic recorder also for bats. So yeah, and you can have the DNA. If you're good in genetics, it can be your next job. You will work to do metabarcoding and environmental DNA sampling. I want to show you also a summary about that. So have a look. I leave always some references if you want to know more. Anyway, I will give you the link for my presentation. Just to click after that on the link. So when you want to do biomonitoring, you can do it in every ecosystems, even into the space actually. Yeah? And you can take, for example, for marine sediment, you can take some biofilms. You will have specific organisms in water, also in sediment, etc. And then in water, if you want to target vertebrates, just take some waters. Obviously, it will be harder in sediment because obviously you can have dead animals, but I mean vertebrates, but with degradation, depend on the condition of degradation, conservation of the body, but you won't have it. So depend of which taxon you want to record, but you see you have a lot of choice. Okay, you want the vertebrates living in your marine systems, take a bit of water, and then you will have everything. Okay, you can do it in fresh water. Quite often it's widely used in a pond, river, so super efficient. Application, yeah, just to remind you, so this summary comes from the paper over there. It can be to check for invasive species. Oh, you took a bit of water, sample of water, and then you record now your invasive species. It's here. So even if you can, it's too discrete. Okay, it's still cryptic. Anyway, it cannot escape to your DNA analyze. Okay, so it can be for invasive species detection with dung, for example. You take a piece of the feces from a predator, and then you will record. Maybe he will record for you many species. Okay, obviously that he hates. They made that with gorilla, for example, and then they found a lot of plants. Ah, cool, the gorilla did a census for us, a census of plants, and also now we know what he eats. And they found some, I don't remember, dikers, I think. So meat, they found an animal. So either actually gorilla are meat eater, and then like all great apes, I saw bongo eating chimpanzee, orangutan eat fish and a little piece of meat with a little, but maybe gorilla too, or because it's very surprising, so it can be a contamination. For example, the diker passed close to the dung, and then a little bit of dust came. So you see, we have to watch out. Can be to check who's dead now after pollution, to check the quality monitoring, air quality monitoring, plant pollinator interaction, ocean ecosystem, and obviously to check just your ecosystems. Okay, this is other application, but it can be just for to have a 0.0 of your ecosystem. So super cool. eDNA, I guess you heard about that, but anyway, it's just to refresh your mind about biology. Okay. Then, when you have all those cool data, what we're gonna do? So it's the next video. I will do a video for 3 of those analyses. First of all, you want to check always if your sampling effort is enough, is representative. If after one transect you found, for example, 30 species, after that second transect you found some of them, and you found few more, with 3 you have that, and you see that wow, you don't have, you plateau, you did not reach a plateau. So after 3 transect or traps, it's not enough. You need to find this famous plateau to be happy with your effort and to be able to say, okay, I have a representative sampling effort. Okay, I'll do a video about that, how to do it automatically in R with vegan. Then same, but if you are only here or here, can you extrapolate to find how many species you can have? Yes, we'll extrapolate by cow, bootstrap, jackknife, resampling methods. Also, automatically I will show you how to do it. Also, I will show you how to calculate the famous biodiversity index, because the number of species is not enough. We need to know if it's an ecosystem with a good evenness. Here, for example, you have 4 species and you have 4 green, 4 hawk, 4, so you have a kind of equilibrium. But you can have also only 4 species, but very rare species like this one, and some very abundant one. So this community is not the same. Even if you have the same number of species, 4 and 4, this is not the same community, because you have different species evenness. So let's have a look and how to calculate automatically PLO, evenness index, Simpson, Shannon, etc. Okay, you will see it's quite easy and automatic. But if you have 4 species on one side, 4 species on another side, same evenness, okay, same index, but you have a cow, sheep, a dog, a cat, and on the other side you have a elephant, hyena, lions, and cheetah. Is it the same ecosystem, same community? Not at all. You need them to do a community analysis. Okay, so I'll show you how to do this kind of comparison of community, okay, in the next videos. Voila, so we saw we did a little refresh about the biocensus, why we use them, the different methods, and again there is more methods, some automatics, some with biologists on the field, the old school. Sometimes you cannot escape the old-fashioned way on the field with Google binoculars or whatever, and you have to be on the field, and sometimes a drone can do it better than you, or even the DNA if you're lucky. Just to do a bit of brainstorming, please, I give you a few scenarii, and then write into the comments what is the design for census in those different cases. Please write, all of you. I talk about my students. Write, my student, please, in the comments how you will design your census for example, the ants. Here it's Vasmania oropunctata, the little fire ants. Very nasty ants coming from Argentina. Now they are almost everywhere in tropical area and even in Israel. So they start to come in Mediterranean area, and it's tricky because I published a paper about that. They divide by 3 the biodiversity in insects. You are the biologist. You are in charge of an island, protected island, and now you have this bio invader. You are this alien species, and you want to quickly check the impact of this species on your insect community. What is your design? What kind of method do you want to use to check the biological impact, ecological impact of the little fire ants on your island? Here, let's say you are in a forest. You are the curator of this forest, and you want to check how many endangered tree species you have. What is the best for you? What is the best biocensus, the best methodology? Please tell me into the comments. Here you manage a marine park and you want to check the protected effects. Okay, no fishing in the park comparatively to the next coral reef, which is not protected and then fished. Okay, so you want to check the ecological impact on the communities, on the different species. What is your design? What is for you the best techniques? Here, let's say also you have some bats, and they want to make a wind farm, but we are afraid about the effect, the potential effect on bats. What is your design? Okay, to check the potential effect of wind farm on bats community. Here, it's what they do, as I told you, in a lot of country. You want to check the evolution, the change or not of the birds communities in your area. What do you think is the best protocol? Please write into the comments. Just a little brainstorming. I will reply to all of you. Okay. Then what else? So evolution in time. It's actually what, as I told you, we do in France, in Germany, in a lot of area. Now it's already functioning now every year. Same here, another scenario. Let's say you had some biological record from the past on a coral reef, and you heard about a bleaching event. Very sad. For example, El Nino, but now it's almost every 1.5 years, almost every year or 2 years, and you want to check the ecological impact of the bleaching. What is the best survey method, okay, for biodiversity census on the corals? Please write, okay, all the scenarii about biological census. Please write what you think is the best in the comments. Okay, so 10 minutes, think, relax, think about the best, time consuming, money consuming, the most accurate protocol. Okay, and then we'll reply, exchange on the comments. I'll prepare and I give you the videos about how to analyze those data. See you.